Hello, everybody, and welcome to Handmade Hero, the show where we code a complete game live on stream. We have to do some lighting today. Um, we sort of put things into, actually, I would say, a pretty nice place at the end of last stream where we had a decent, or at least decent enough, uh, representation of the world, and we did some bounce lighting on it. And the problem that I think we had at the end of the last stream was just that we don't really know at the moment whether or not it's actually lighting correctly. We sort of, we did the basic, so we got the basic stuff implemented with our new scheme, but we don't have any sort of real well-constructed tests in there to really determine whether or not we're actually performing the computations correctly. We put in a thing that does raycasting against essentially like quadrilaterals, and we didn't really do any sort of verification that that ray test actually works. And so I think when we looked at the results, it looked like maybe that wasn't really working correctly, or at least, maybe something else was wrong. So we kind of are getting close to having something we can sort of iterate on and refine down to something that we want. But I think we're still at the point where we need to do a little bit more sort of testing and checking on it. Maybe construct some structured tests where we can verify that it's working, or at least draw some things that would let us know. Oh, Handmade Ray is still up. That just loaded Handmade Ray. Here we go. We need Handmade Hero. Okay. So if we take a look at what happens here in the world, if I run the lighting, you can actually see what we've got here. Here is like a subdivided version. One of the things that we added was the ability to subdivide services down to get sort of a higher resolution result, right? And we can sort of see that the things are sort of making sense. I mean, there's some things that indicate, correct behavior, but there's definitely other things that, maybe don't. If you look at like what's going on here, I'm not 100% clear on why this would. Oh, hello. I don't know why these are running. Can we stop? Can we? Yeah. Could we just get rid of that? There we go. Just yeah. All right. Sorry, I don't know why the diagnostic tools were like tracking that there. I was not trying to run a performance profile. So anyway, so if we take a look at what's going on here, we can sort of see that some of it looks reasonable, but some of it maybe doesn't. And I think, like I said, it's going to be hard for us to converge on a good lighting solution unless we maybe get a little bit more information about whether things are working the way that we think they should work, and so on. We also have some other things that I think are pretty indicative of stuff that should be modified. If you look at like what this giant plate is here, that's actually the hero, right? And one of the things that's interesting about that is that it should really be pulling its lighting from something that's more representative of what it represents in the world, and not necessarily its sprite plate, right? Because its sprite plate is not necessarily where we want to light the hero, right? The hero may want to be lit as if it's straight up and down. So it may want to be pulling its lighting from an interpolator that's different from where it's drawing its lighting because of that faux 2D aspect of it, right? So that's also something that we're going to want to take a look at. But as you can kind of see, we're getting closer to something that's sort of usable. As the hero moves around in here, we do have, sort of light playing across it, and it does interpolate smoothly, like we're not getting a lot of artifacts and stuff. We do have a little bit of sort of a directional banding aspect to it, so we're probably going to want to do something to address that. That will probably be as simple as making sure that our sampling is a little more jittered. And it's kind of subtle. You can't really see it that obvious in most places, but you can sort of see it, that sort of bias that occurs because of the fact that our lighting is done on voxels. All right. So if we switch back here and take a look at this, man, I'm struggling today. Get some water here. What I would like to do again is just maybe sort of start to figure out whether we've got reasonable equations in there for example for the raycasting and also for the way in which the light is getting transferred. And there are definitely some things in there that kind of feel like maybe we're not getting very reasonable results from them. I don't actually know, like, if I look at some of these things, it does seem a little odd. I don't know how many rays per element we were casting, but in this case here, for example, we're getting situations where certain lighting elements have like overwhelmingly blue or overwhelmingly red right next to each other. And in order for those sorts of things to be true, for example, we would have to have like only one hit in either direction. That's not entirely out of the question, obviously, because we sort of have light only coming from those two places, and directly above is not actually producing any light. So I could sort of see that happening. One of the things that we probably do want to do as well here is put in some kind of ambient lighting that gives it just something besides the basic light that's coming in. So that we don't have such strong directionality. In this case, we've got just one light that's right here. It's the only light in the entire world, so everything has to be bounce light that kind of comes from this light eventually. And again, so if I look at how this is working, some things that make me a little uncomfortable, you can kind of see that in here, we've got like sort of some of these things can't see the light at all. Others of these things can, like for example, trying to see if I can zoom in here. There we go. I would expect in a lot of cases, like for the light, which is this thing right here, I would expect it to not be able to see, for example, this element right here, but that element is lit. That seems very peculiar to me. I also don't understand why these can't see the light source. Maybe they randomly picked wrong. But again, it just seems kind of like maybe we're getting some faux results here that I don't necessarily trust. So I'm going to try and figure out a strategy today. I think the job for the day is going to be, I'm going to try to figure out a strategy today where I can try to validate some things about our raycasting and some things about our light transfer to just try to debug it under the assumption that there are bugs in it. And while I don't necessarily know that there are, I just think we have some strong indications that there are. Again, another example would be like right here. You can see that there's no light on these, even though the light is right next to it. And it would seem like almost anywhere you could have picked on here would have hit this light. And I don't know why, right? So just a lot of stuff like that is just making me nervous. So although this looks like it's doing something that sort of resembles a lighting solution, I suspect we've got some serious bugs in there. They may be subtle math mistakes or something like that, but they create serious problems, I think. And so I want to go ahead and take a look at those just sort of methodically today as much as I can. So if I bring up the render group here, and we take a look at the lighting equations, I think we got them right here. So here is our raycast. So what we'd like to do is validate this raycast, validate that it's actually working, and that it does what we think it's supposed to do. And then the other thing that we want to do is this compute light propagation here. Compute light propagation is the thing that actually spreads the light around and uses the raycasts. And we want to try and figure out whether this is sort of correctly setting those light values on each iteration. I don't know how many iterations we're doing right now. So we do 4. And then the final gather, that is just the thing that looks from a particular surface and tries to see what kind of light it's getting. Obviously, that can also have a mistake in it, and we'll have to see. I guess one thing that's interesting about the final gather is that it kind of throws away the information that we've already used when we spread the light around, kind of. Right? Which is kind of odd, because each of these surface elements, it already had in here emission information stored. So I suppose we probably should be using that emission information as a guide in some way, probably, or at least find ways of tracking that emission information. Maybe while we're doing this compute light propagation, it would seem, right, like as we go through the emitters and we push things on, it would seem like you would want to build this up. Yeah, hard to say. But anyway, so this again, even if the raycast was working properly, there might be something we're doing in here that's dumb. And if we went ahead and looked at what's going on there, we could maybe figure out some sort of maybe accumulation bug, or there's also, of course, just how we're sampling that might be dumb. So there's a lot of things that we can do in here that you know might be important. Even just this way of sampling the hemisphere is probably not great. So even that can be improved. I don't know that it's necessarily buggy, but that's that's definitely something we could fix. All right, so let's first start with an inspection of this code and make sure that it makes reasonable sense to us. And then maybe let's try to construct some test cases that lets us know whether or not we're actually doing this raycast properly. And one of the things too is when we're calling this raycast, right, we should verify that we're actually calling it with the right things that we think we should be calling it with. All right. So a couple things here that also I would point out. So when we're running through here, right, we're looking for a closest hit as well. So we're a sort of, when we don't get a hit, this is where we would put in the ambient lighting. If there was going to be like a skybox or something like that, that would be what would be in here. So if somebody like shoots a ray and never hits anything, this is where we would put that. And just as an example, like, you know, if we said, for example, this value right here, which is the result color, I think well, I guess not. I was going to say, I think this would be okay, but doesn't actually look like for the light spreading anyway. So it would have to be in here where we get this incident color on the raycast. Yeah. So during the final gather where we do the raycast, we retrieve an incident color. And what we could do there is say, all right, so it's free for us to just return an ambient color here. So if we wanted, say, like a gray skybox that was going to come in, we could do so pretty trivially, right? And then when we ran the lighting, we would have ambient light. So for example, if I were to run it here, I should get some. And you can, so, you know, looking at that, the difference that created alone is pretty, like, that's not what that should have done. It looks like we've got some overflow problems. Like, adding light should never have made the scene darker. It looks like we've got some problems where we're passing something over bright, like we're not clamping the light amount or something. I'm not sure how that's possible. Like, we do definitely clamp. But we must be doing something weird there. Yeah, I mean, I think we've already sort of hit upon a bug. Because adding more light to the scene should never be able to do that. So we're doing something real dumb here. I guess one thing is the normals are typically bent in the direction of the strongest incident light, and I suppose that could be, that could be something. So let me just take that out of the. I don't know if you guys remember this, but one of the things we were doing is saying, well, let's go ahead and produce normals that are weighted by the direction that the strongest incoming light. Let me just see what happens if I get rid of that. Yeah, so that doesn't really affect it too appreciably, it looks like. So yeah, I guess all I could say is we definitely got some bad bugs in here. So now it's just a question of finding out what they are. Looking at this, I mean, it's pretty straightforward. We start with a 0 accumulator. We accumulate colors. We write those colors back. That's really it. So I'm not sure how that could really be all that weird. We'll start with obvious stuff. If the incident light was always just pure red, just a pure red light, what do we see, right? And so that's kind of strange. So if I was to leave the average, if I was to set the average direction to the light to be just the surface normal, and then I was to set the incident light to always just be red, I should just see a red scene, right? I mean, that's what I should see. But that is not what I'm seeing. Like, that's just kind of somewhat nonsensical. So yeah, we got to figure out what's going on here. I don't really know what's going on. So when we output our lighting quads, I guess the lighting quads, we're outputting just the emitters though. So I guess that actually makes some sense, right? So these are just the emitters. If I switch off from just the emitters, this is more of a representation of that final gather, right? But looking at that here, I mean, it's still wrong. You know what I'm saying? It still looks roughly to be that same problematic look. So what's going on? I have no idea. I guess I'm just going to step through this and see. Because if we are cold setting the incident light and the average direction to light, those are the only things we actually use, right? Of course, we did make it greater than 4096. Taking a look at lighting textures here, I would say that, well, there are a couple things that we should probably probably try to do here. The first is that if I look at what's going on in the OpenGL code, so here's the program that actually does the lighting. So if I take a look at the lighting code, that's right here. And you can see that it's doing, I mean, exactly what you would expect. It's taking the light and it's doing a distance fall off, and it's doing a cosine fall off on wherever that incoming light is. Right. Yeah, there's just so many things going on here that sort of need to be separated at the same time. Because for starters, since we've got this voxel lighting going on, I don't actually know why we would be having light positions involved here at all. Because the light positions we don't even know. I mean, I guess this is just because we're trying to do a blend here of multiple sample points, and we're trying to get those sample points to interpolate. So I don't actually know. I don't actually know that there's really distance fall off here per se. This is really just a case of taking a couple scattered sample points and combining them together. So this is really the only fall off. But what I would say is this probably shouldn't be part of the contribution equation, because the contribution should be entirely, like, the contribution of this thing should be based on the interpolation between the samples. But that contribution should not be modified by the directional fall off. The directional fall off should just affect the light. Right? So it should look more like that, or perhaps more to the point. So something like this, where we're saying, like, all right, we've got the contribution amount that gets multiplied in, but we've also got the directional fall off that gets multiplied in. The directional fall off doesn't count for renormalization, right? Because we don't want the light to get brighter. The fall off will create the light dimming effect as the angle gets steeper. But if we were to track that in the contrib as well, then when we renormalize, we will, of course, renormalize it away, which we don't want to do. So I think that was just kind of a mistake there, right? So when we're doing this RGB here, and we do the 1 over result A, this maybe also needs to get clamped. It's hard to say. I mean, I guess if we look at how this is working here, the contribution of these samples as we go through them, I mean, I don't really even know, to be honest, whether this should be doing, do we really want this at all? Like, so this represents the location of the light in the world. It's not really a light, right? What it does is it represents a location of a lighting sample that we took. And so we've got two levels of blending going on here, right? We have a voxel blending that's going on, and then we're lerping between those. But it's unclear to me that we even want to take this light position into account. Like if we actually want the voxel lighting to be just a straight voxel light, we wouldn't do that. So whether this makes any sense or not, I'm not sure. What this is basically doing is saying as I get closer or further from a particular light sample, I want to diminish its contribution. Right? And when we renormalize this, we're basically saying we want that to be brought back up to 1.0. So no matter how much we added here, we just want to eventually make sure that it's even. What you can see here is, although this gets clamped from 0 to 1, we're summing a bunch of them, so it could be very well higher than 1. But in theory, this should knock it back. So I don't see any real way that could overflow. But it's hard to say. What I do think is clear is that the directional falloff, though, should not have been involved in the contribution. That's just a straight up... Oops. Expected times equals comma. Oh, unexpected times equals. Oops. I agree. Times equals doesn't make a lot of sense there. All right, so let's keep moving on. So that, was not a particularly relevant part of the lighting solution at this point either. Although you can see it made some difference. It doesn't seem to super make a whole lot. Like we still get all kinds of weird stuff happening, and we're still not getting that ambient light that I thought we should get. So we still got lots of problems here, which is actually good news. The more problems we have, the more likely our lighting will get better as we fix them, which is good. All right, so, but I don't see any ways that this can overflow really. So I think that wasn't the problem. I think something else is the problem. I'm just not sure exactly what. So let's ping pong back over here. So we got the incident light and the average direction to light. They're hard set. So right now things retain their surface normal instead of bending it towards the light sources. And we have the incident light, which is just supposed to be set to red. What we would expect about that after doing gather final lighting, we would expect that if we drew the incident light and the average direction to light, we would just get pure red. Right, that's what we would expect everywhere. Because when we come through here and we do the output lighting textures call, when we come through here and we output our linked list of light samples per voxel, then what we would see here is we should see this incident light getting 100, which should end up giving us a 25500 value that we pack in there, right? So I guess what the first thing I could do is just verify that that's actually what's happening, but that's what we would expect to be happening, and that's what we would expect to be sending down to the voxel layer, right? So I should see here's where we run the output. I should be able to see in the incident light. Oh, sorry, we're still running debug big build here, which doesn't really let us inspect the values. The difference in speed between debug and release is rather pronounced. So here's the incident light values. They are what we expect them to be, so that's good. And if we look at the packing version, that's exactly what I would expect it to be as well. And so when we actually go to send this down, yeah. I mean, that looks fully correct. That looks exactly what I would expect. Let's take a look at the average direction of light as well. In this case, we're looking at negative z, negative y. So these look like surface normals to me. So that all looks fine. Like we've got, you know, most of our things are cubes in the world. That makes perfect sense. So that all seems pretty good. So yeah, if all of those things are getting sent down exactly that way, I mean, one problem that we do have, right, is we don't have a way of directly visualizing the lighting quads here, because when we do an output lighting quads, those lighting quads are going to get lit by the voxel itself, which messes up our debug view, right? So like, for example, you know, when I run this, switch back to release mode there, so we have a quicker turnaround. So if we take a look at what happens here, right? All of these emitters that we're viewing right now are also being lit, you know, by the Z-bias program, which we don't actually want if we just wanted to see what their pure emission values are, right? And that's why if you take a look at what you're seeing here, it's when we switch back to doing actual rendering, there's a lot more light. That's because the emitter quads version is showing the result of just the emission bounces, whereas this is showing the result of the actual gather, right? So yeah, that's all. But again, so if you take a look at what we're seeing here, the result of the actual gather, again, doesn't make a lot of sense, because I'm throwing away that information. I'm not actually recording the actual gather information. I'm just setting the incident light color to red and the direction to be whatever the surface normal was. But you can see what I'm seeing here is actually a very distinct set of patterns that are not constant in any way. Like, they're very variable. They, you know, they have way too much information in there for something that was supposed to be hard set. So we definitely have some problems here. Again, I'm just trying to slowly move towards what they might be. So what got changed here? So again, going back to the shader code, I'm kind of wondering here what I am doing that's making such a weird thing happen. Now, if there were no lighting samples in a voxel, then this wouldn't produce any light. And now that I think about it, I'm not sure why this is result.a greater than 1. Because it should renormalize regardless, right? It should be if it's greater than 0. I don't know where that came from. Because it always should renormalize the contribution, so that's just weird as well. Right, so after you like add all the contributions in, you should get something that renormalizes back to 1. So that was also a mistake, probably because we made so many modifications to this code, you know, stuff kind of gets squinky in there. But again, you know, just absolutely nonsensical results here, right? Like, this should be, like, how is it black? It should be pure red. And I have no idea why. So again, let's start with some sort of obvious stuff here. I'm going to stuff the color value here. I'm just going to tell it that the color is green. Always. So no matter what voxel it happens to be picking for lighting, it will always think that that voxel is green, and we should get just pure green, right? And it looks like we do. So this is just green times the value. Okay, well, I should have guessed that, I guess. So that's why under a pure red light, I guess it does make sense that the blue surface, which cannot reflect any red light, that makes sense. Okay, I'll give that one to you. Fair enough. Okay. So we're going to just return pure green light here and verify that that's okay. These are both black because the red and green surfaces don't reflect any green light. So when they multiply, they won't get any results. That's totally fine, looks like. I'm going to go ahead and set it to pure blue light. Again, that looks okay. And pure red light. And that all seems pretty reasonable. I'm not sure why these steps are darker. I don't know if those steps are supposed to have a darker color to them. So I'm a little unsure about that, but all right. So that all looks fine. So if we were to stuff the voxel with 1s, we should just get a pure, yeah, and we do. And okay, so these should be darker. They were green, whereas the ground is white at the moment. So that's fine. So the voxel interpolation isn't like totally busted or anything, right? It's producing sane results in the case where we just stuff a white light in there, you know, everything's fine. So if I was to then go and say, well, okay, let's pretend that every light that we loop through has a known set of values. So the light color, let's say, was white. So every light sample here is going to be white. I would expect to get that the direction fall off is going to be 1.0. So there's no directional fall off and the light color is white. I should see just pure white now. It didn't like that. It's 'cause I tried to redefine the variable. Assignment of incompatible types. Light color is not ever used anymore, so that's okay. So we'll do that. All right. Too much. Yep, I agree with that too. Sorry. Too many typos. All right. So now I'm assuming that the light color is white, and I'm summing it together. So here is one where we basically have, you know, white light samples everywhere. And you can kind of see that this is bad. Because here we just have nothing but white light samples, and yet we still get places where things are wrong. And I don't know, I'm just assuming that the reason for that is because the voxels in that area didn't get any sample values in them. Like this happens to be a voxel that just doesn't have any data. And so when it goes there, it can't figure out what the color must be, right? And there's a couple of different ways that we could, you know, try to fix that. We could try to add to a given voxel. We could try to like add, you know, duplicate light sources that are near the boundaries of voxels or things like this. But this is kind of a problem with this lighting scheme that the voxel lookup doesn't super handle very well, which is just that fact that it can't really, it doesn't grab the light from everywhere that it would necessarily need to grab the light, right? And this is one of those things where, like, you know, we could imagine running something on our voxel that would sort of spread the light out. Especially if we go to some scheme where we actually just have the voxel itself has a bit of like what's the light going through it, which is kind of what we've been moving towards, but we haven't quite gotten there yet. But again, you can kind of see some weirdness here, right? Like why are we getting these sort of darker patterns here? You know, what's going on? So looking at this, there's a couple different reasons for this. Like one could be because the contrib values were bad or wrong, because we know the directional fall off is not that anymore. But you know, we're summing up these contrib values and then we're normalizing by them after the fact. So that should just be taken out of the equation. So the only really thing that should be possible there is if there are no light indices at all. So, you know, how could we test for that, right? So let's go ahead and say if there was no light index, so there's no lights in this voxel at all, then what I'm going to do is I'm going to set light, or just the result. I'm going to set the result to pure yellow anywhere that there's no light sample. So I can verify to myself that that's actually what's going on, right? So here is that. And what you can kind of see here is that suggests that no, that's not what's going on here, right? Something that we got a different bug. Because you can see it blurring towards yellow on the outside of the voxel where there might not be anything, I guess. You know, maybe I'd say that. Oh, but you know what? That's a blue light. So So how would I go about that? Because the problem is this gets multiplied after. I guess what I could do is temporarily. So here's one thing I could do. Let's get rid of that for 1 second. And I'll go in here and say, okay, during this surface select RGB times L bit, I'm going to just actually set it to the light color. So now, whatever the light color is what we will see. Right. So this is whatever comes back from the light color. And you can see that, you know, it's sort of darker in here, right? So those are the light colors that are incoming. So if I come back here now and say, all right, why is that happening? Now, if I wanted to, I could say if light I equals 0, well, okay. In that case, the result is going to be equal to that bright yellow. So now we should be able to see that bright yellow anywhere that, you know, we're getting incorrect lighting results or can't compute lighting results. Correctly, everything is yellow at the start because the voxel is completely empty, which means it's not finding any lighting samples. Then when I go ahead and move on here, what you can see is like, yeah, we're getting exactly the problem I was talking about. You can see that as we look through here, there's just a ton of places where there's just no lighting samples to pull from. So the next question, I guess, is why are there no lighting samples to pull from? And a closely related question would be, can we do something about that? How bad is it, right? So let's take a look at what happens if I set this to red instead of yellow, so it's a little easier to see, like with a pure red. And what you can see is that there's some places, like right in here, that seem pretty bad, but honestly, a lot of the places are only trending towards a location in the voxel that doesn't have samples, but they're still inside a region that does, right? So one thing we probably want to do is let the contrib value flow all the way through, I think would be my suggestion. So instead of renormalizing the voxel sample here, I think what we want to do is actually have some voxel light return the full V4. That way the contribution value is tracked. And then when we come through and do our voxel summation here, what we could do is try to make the lerping respect that, right? So if we grab each of these, we now would have, if we restore the actual V4, we would now know what the voxel lighting was in that area and whether or not we got any samples, right? Then when we lerp, we could try to take this into account, right? We could try to take into account that lack of lighting as necessary. Right? And so, yeah, like imagine doing something here called voxlerp. And again, a lot of the stuff we're gonna have to think hard about because, you know, you can't be doing as I'm really like just playing with the lighting here and trying to figure out stuff that we think can work. But this is like pretty expensive stuff that's going on here. So it's not necessarily a given that we would be able to do any of this stuff actually in the shipping version. But we're just trying to find something that can work, and then, you know, we'll optimize it from the working version as much as we can. But with lighting, again, we just have to find something that works first, and then once we have found it, then we have to try and figure out how to get it to run reasonably, right? So here is a Vox lerp that's just going to do the straight lerp exactly as it was doing it. Ooh, but somehow that changed the result? What happened there? Oh, right. This has to renormalize at the end. So there's, oddly enough, that already looks better, which doesn't make really much sense to me. Although I guess the fact that it's doing the voxel interpolation using the contribution values is itself enough. Yeah, that's pretty interesting that that alone helped. But then what I was going to say is when we're actually doing this this lerping value, what I wanted to then do was say, all right, let's just assume that the result is L0, right? So we'll just start with that. And what we'll do is say if L1.A is 0, or I should say if, I'm trying to think of how to write this exactly. Maybe something like this. So I guess say if L0's alpha value is 0, so there's no samples there, then we just want to use L1, right? We're not going to blend between them because we can't. There's no light there. Similarly, if L0's is all right. Actually, now I think about this, we could. I'll keep doing this just for fun, but we could actually do this in an easier way too. What we could do is just for every voxel, when we set that voxel value, we could look to see if its neighbors, or rather, for every voxel in the grid after we're done computing it, for any voxel that doesn't have any lights in it, just set its light pointer to point to the light of some voxel in its vicinity that does have one, right? Because then we wouldn't need to do any of the special casing. In fact, I think that's just better, because that incurs no speed penalty like this does in just the regular case. So I think that's actually better than what I was doing. All right. All right. So I think what I'll do is I'll do that. Yeah, I'll come do that. I think I might take a quick break from streaming. But let's do that when I come back. Let's loop through all the voxels, and what we'll do is we'll set neighbors equal to ones that any empty neighbor will get set to a full neighbor in the way. I'm going to take a quick break from stream, and then I will be back in just a few moments. Okay, back to it. So yeah, I think the first thing that I do want to do then is just try to get it so that we're not sampling from places that don't have samples in them. And I think the only way to do that is just to make sure that we get that we always flood fill our voxel essentially, and make sure that things that don't have anything in them take something from their neighbor where possible, right? So here in output lighting textures, right, what I could do is say, you know, much like we were doing in this loop here, what I could do is do a simple sort of directional fill after the fact here. So this is our lighting textures, output lighting textures function. So right here where we go through each of the values, what I can do is just look for any given one of these, look at its neighbors if it's 0. So what we could say is like, all right, if we take a look at the thing that we were packing here, which is lookup at, this value right here, voxel z, y, x. If I was to go ahead and look at that and see that it was not filled, then what I could do is set it to like a neighbor value. And all I would do here is look to see where I could find a neighbor value, right? Now for simplicity, I think what I'll do at the moment is I'll just go ahead and only search just the, you know, reduced set by 1. So I know any time I find one, I can just look at each of the direct neighbors to see what's in there, right? So I can say, all right, neighbor equals dest lookup, you know, z minus 1, y, x, like so. And then I can do like neighbor equals neighbor, and just look through each of these in turn. And again, this is only when we initially create the voxel that we're doing this. We're not doing it on every lookup, right? So we'll look at z plus 1 and z minus 1. And I don't know how many of these we actually want to do, but, you know, I guess in this case, we probably want to do it this way. Here we go. So here I'll do like all the z minus 1s. So we'll do z minus 1, and I guess we could just do all of them here. So we'll do all the z minus 1s. We'll do, I almost want to do this in a for loop. There's so many of them. But I'll do the z minus 1s here, and we'll do y minus 1 to y plus 1, like so. And in each of these cases, we would do x minus 1 to x plus 1, right? So here we have all the combinations for the z minus 1 layer. We've got y minus 1, x minus 1, you know, minus 1 plus 0, whatever. We would do this for each of them, like so. Kind of an unholy terror. and all we'd be changing was the Z layer part of it. And that's it. So this should propagate. It'll just search the neighborhood of the voxel. And if it finds anything that it can use as the pointer to the light samples, it will use it, right? What's it saying? U16. There we go. And that's it. So, I don't know, hopefully that would give us something where we propagate those light values out to neighbors who don't have any light values. And we'll see what happens. So I don't see any difference there at all. That looks exactly the same to me, which is weird, right? Because that should have allowed to grab some neighbor light values there, which it doesn't look like it did. And I don't know why, right? We don't really need that anymore. That's a little peculiar. So I guess, well, you know what though? No, it maybe isn't. So because the voxel, that could just be on the edge of the voxel as well. In fact, I think it is. Yeah, but even so looking at that again, since the voxel boundaries are presumably relatively tight fit to the scene, what we should probably do is also expand those. But again, since this isn't actually doing that search, it doesn't have an apron there, right? So, you know, if we really want this to go all the way to the edge, it has to actually not have these 1 and -1s in there. But even that, so let's take a look at some we know aren't on the edge, right? We know all of these are not on the edge, right? None of those are on the edge. So again, it's kind of busted. Like, there's just a lot of bugs in here. I have to figure out a good way to sort of pare this down, because there's just a lot of stuff that isn't making sense. So we have a lot of problems, but it's hard with something like lighting to figure out exactly how to go about tracking them. I'm sort of using the structured art procedure here to do it, where I'm like putting in known values to see what happens on the way out, but it's not really sufficient. And it feels like we're going to have to construct a more rigorous test case if we want to get anywhere on it. So if I step back for a second and just say what you know, let's verify that that's working at all just first, because that should have filled interior nodes and it doesn't even look like it was doing that, so I'm kind of not sure what's happening there. Visual Studio is so bad at telling you anything about what your code did in release mode. I guess what I can do is set something So in this case, what I'll do is I'll just stop, assuming that it filled something in, I'll stop the program there. So it should crash there, I mean, well, assert there, right? If I ever fill in a value. So yes, you can see that I am filling in a value in theory, right? And hey, it looks like it wasn't optimized away this time. So, you know, it is finding a value there, and it is actually doing a, you know, replacement of whatever this previous value was, which was 0, is now getting replaced with, of course, is now getting replaced with an actual value. So it does seem to be doing some fill, right? It does seem to be putting some values in to places where they weren't previously put. So that's good. But it doesn't solve our problem, right? Like we're still seeing exactly what we were seeing before to a first approximation. So the question is what to do next. I'm gonna get rid of this for now. Leave it in there in case we want to play with something like that later. Oops. All right. So, again, focusing on this just for a second. These locations are places that just don't have voxel lighting samples, right? And some of the patterns that I'm seeing are just really strange too, right? Like, I don't really understand this pattern here because it should be a fairly straightforward voxel pattern. Like, it shouldn't be something that's got like a circular feel to it like that. I don't know. It's very strange. I don't understand the results at all. Like, I'm completely at a loss to what's actually going on there. And again, I think part of that is just this sort of issue with too many things going on, not well enough tested. If I go through and set here if I take a step back from here and just say, you know, if I just took the voxel values themselves and I draw them. So this should give us like kind of a rainbow sort of a look, right? Based on where in the voxel you actually are. And you can see it sort of does, right? Now I don't remember, and I have to look, what the voxel... So our voxel is only 8 by 8 by 8 somehow. So actually that's a more reasonable normalization vector there. So this is just an attempt to verify that the voxel interpolation itself didn't become broken. And that looks reasonable, right? That's a nice color wash. You know, I don't see a lot of artifacting on that. So it seems, anyway, at least a first approximation, that the voxel interpolation is fine. So that's fine. So it's just what we're returning from the voxel that's somehow producing that patterns. So this must be pretty busted in here, right? Like where we end up having contributions and don't or something must be pretty bizarre. So let's start again by doing some things that are relatively simple. Let's just ignore all of this stuff entirely. And let's just set the result to be green or red based on whether or not there was a sample. And so this should give us something. Obviously starts out all red because there are no voxel samples. And now it's green and there's only red where there aren't samples. Right. Now, again, I really don't quite know how it's possible that there's no samples in wherever we're interpolating to. But I guess that's because, you know, like if I had to, let's say I had to assume that there wasn't a bug, then the reason that we're getting, say, red in this area would be because there's a voxel cell right here where there are no samples, right? It would be nice to be able to see the voxels easily, so I wonder if maybe I should do that real quick. We already had a way to draw that, right? It's this one right here, yeah. So I think it's actually this. So here you can sort of see the lighting solution visualized in voxel form. And anywhere where there is a sample, there will be a green cube. And so, you know, here's a hole right here. And you can see that is probably what's happening right there. So let's turn on the filling. Oh, you know what? I'm an idiot. The filling we were doing before the packing. So that... Well, no, but that's fine, because we're updating that texture directly, though. So, I'm not an idiot. I mean, well, I am an idiot, but I'm not an idiot because of that. I think it's important to remember. So if we go ahead here and take a look at what we end up with, now there isn't, I don't think, any hole there, right? Yeah. So that did work. That whole filling. So let me go ahead and try to do something a little more sane here. Oops. So what I'm going to do is I'm going to turn this into a for I loop like I was saying I wanted to. Oops. And when I'm going to look at this value, I'm just going to do like plus dz plus, oops, plus dx plus dy, like so. I'm just going to turn that into a for I loop like I wanted to do, which again doesn't really help us yet, but because I want to do a slight change to it so it can fill everything. So what I then want to do is I want to be able to take these bounds here and widen this up to look at the entire voxel. And so here I just want to say, like, okay, you know, if z equals 0, then I don't want to look behind. I just want to start at the current z level. And if z equals light lookup z minus 1, then I don't want to go ahead. So this is right the new way that's actually clamped. So this way we can do this on the lookup. Oops. Missing a parentheses there. There we go. Not sure why I didn't quite get that. There we go. It's been a bad day. All right, so anyway, we can look at the XYZs there and clamp them so that now we're only going to run within the legal offset for wherever we are. If we get to the edge of the voxel, we won't look beyond into the void, right? Into a legal place, or at least, well, that's what I tried to do, but I obviously didn't quite do it right. Because I missed one there. And so now we should be filling basically everything or anything that had a neighbor even close to it. And it looks like now we're pretty close to good. And so I think all we would probably have to do is clamp our voxel lookups to not interpolate outside. So if we take a look at what's happening here where we do this texel fetch here, that voxel at, you can see it's not like clamped at all, right? So if it was going to look outside of where the voxel was, it just would. And we don't really want that to happen. So when we go to actually sum this, what we want to do is clamp these at values. We know we shouldn't ever not really sure. We don't really pass down the voxel here. So, you know, I'm trying to think of the best way to clamp the voxel. So you can see here we do our inverse cell jam times the min corner, right? And we're sort of making sure that we get the, you know, the 8 voxels that surround this point. But some of those voxels might not actually be in, right? We might be looking at a negative or a -1 or an 8, which would be outside. So what we want to be able to do here is say when we go to look this up, you know, we want to be able to do like a we want to do something like this. And this is really just right. And And we want to know what the voxel dimension is here, so we're going to want that to be an actual like included value. Oh, sorry about that. And ideally now, you know, it wouldn't be, if I did that correctly, it wouldn't ever look outside the voxel. So now we've filled all the holes in the voxel grid, and we have that we might look in, right? And we have made it so that it never like looks outside of the voxel grid. It just resamples the same voxel it's in if it would have tried to look outside, because we know there's nothing there to look for. And so now we've eliminated those red patches, which is like important. And what we'd like to do here is like get a vox dimension. And so let's take a look. Let me see about putting this in here. So right here, this is where we would want to do that. So we know we've got this like these constants here, and we would like them to come through in the shader. So what I'm going to do is actually have them literally just come through in the shader as pound defines, right? So we got the x, y, and the z here. There's the x, y, and the z there, and now that way those will be available in the shader, and if we change them, they are properly changed. So what we would do here is say like that. Something like that. And that way we can do in here, we just do clamp vox. And now we should have a way to clamp our voxel to, if we decide to make it bigger or smaller, or you know, whatever else. Whoa! Or not. What did I do there? There we go. Sorry, I meant to pass -1 there. I am not sure where that's coming from. So, yeah. That's where that's coming from. Accidentally typoed. All right. So I think we're pretty good now on that part of things. That all made sense as we went through it. But that's just the first step, right? So now we have to start saying, well, okay, so we figured out how to keep ourselves from sampling voxel values that weren't there. But now we have to make it so that when we sample values that are there, they make sense, okay. So here's taking the directional fall off out of the equation and setting the light value is always equal to 1, but having the contribution value be whatever the contribution value was for the samples. So this is basically now we're trying to get our sample interpolation to be something sane, right? And so that's going to take a bit of work as well. So what we can see here is that once we turn on that part of things, we get a lot of weird like scalloping, like sort of spherical weirdness happening, right? And so now let's try to like hone in on that and figure out like what we're getting here. So fundamentally speaking, inside one of these voxels, what we're doing is we're throwing down a bunch of light samples, and there could be like a dozen of these, right? There could be a bunch of them, which are basically points in space which say we computed lighting at this place. So what we want to do is we want to try and figure out what that implies for the actual pixel that we're trying to light right now, right? So it seems like we would want the fall off and that sort of stuff to make sense, right? What we want to do is we want to have it so that as you go towards any one of these points, since we know we computed the lighting at that point, when you get to that point, the light should be very strongly correlated with what we computed at that location, right? Because we don't really have to do much reconstruction in that case, because what the incident light is at that point is known. It's not like in between sample points where we're trying to reconstruct it. So that contribution value, right, is supposed to be 1.0 when you're right on it, which it should be, because the length of these, the sample point in world space, right, that length should be 0 at that location. And, you know, we want to sort of make it so that that value ramps up quickly, potentially. So it's a pretty tight fall off. So what we're doing here is we're saying, all right, we'll take that length. We want that length fall off to potentially be very fast. But we don't necessarily ever want it. What we'd like to do is we'd like to make it so that it never quite goes to 0, potentially, because we don't want to lose the sample ever, probably, I would say. So I'd say the way that we're doing it right now is maybe not the smartest thing in the world. I would say that the way that we're doing it right now, what we probably want to do is we want it to sort of asymptotically approach 1, right? So I'm not sure exactly what that should be here, but basically what I'm saying is we want a value here, right, where this will go rapidly towards 1 as it goes away from the point, but never quite get there. So that we always keep at least a little bit of contribution from this thing, but as you get further away from it, you get much less contribution. And I'm trying to think of how I would do that, but I'm not quite sure. This value is sort of unbounded, right? Because we don't really know what its maximum could be. I suppose it can't be bigger than the voxel. But that's really all we know about it. And if we were to divide it directly by that value, you know, yeah, I'm not really sure what we want to do here. This is a bit tricky. But whatever the inverse voxel dimension is, right, we know what that is because we've got it. Right, we've got that Voxel dim. So if we wanted to, we could use the Voxel dim here as a multiplier, because since it's already 1 over the dimension of the cell, that would give us something that we knew it couldn't exceed 1. It just doesn't necessarily asymptotically approach it quickly like I wanted it to. I think there's probably smarter math we could do here. But if I went ahead and said, okay, let's take the Voxel dim So if I take this distance and I multiply with that, it should now normalize it so that the maximum distance would be like 1, 1, 1, right? So it would be like the square root of 3, right? How do I do square root on this crazy calculator? Is that supposed to be square root? It looks more like a check mark. Apparently so. All right. So I'm thinking maybe just like, you know, I want to multiply by the inverse of that to keep, to keep the values sane. So I want something like, how do I invert this value? This calculator is nuts. Where's the inv button? I don't even know what to say. Is there no inverse button? Wait, of course, yeah, there must not be an inverse button because here are the two, these are the inverse of each other, and they're both on here. For the love of God. Anyway, I don't even know how to copy a value here because there's no menu on this thing. This is such a piece of... Look at me right-clicking on this. It's not doing anything. Weird. Oh, man. How do you mess up a calculator? Answer? You ask Microsoft to write it. All right, so here's the value I actually wanted. Maybe a little bit too precise. So I'm basically just looking at something that would try to keep things bounded to the length of the voxel. In terms of interpolation values, I don't know whether that's really sufficient though. And so, yeah, if you look at what's going on here from what we're getting, we get these weird like radial fall off patterns. And again, I don't really understand those, so I want to investigate further because remember, we're not actually blending different samples, we're blending the same sample because I'm overwriting the values here. The directional fall off and the light color, which are the things that we actually were computing, I'm throwing out, right? So the only thing we're looking at here is the result of the renormalization by the contrib value. That's all. Now we know we always enter this loop, right? Because if we didn't enter this loop, we would have seen it before, right? So if I look, remember we did this. This is what we were doing before. If I note that we never enter the loop, I can stuff that red value. And the work we did before seemed to be ensuring that that was never happening, right? So that means we always enter the loop. Right? You can see no red. So given that we always enter the loop, what that means is we must be getting contrib values of 0, right? Because of this or something. Right? So I'm going to start by seeing if that's true. So does the scallop pattern come solely from this equation? My guess is it must, but let's first validate that that's true. Maybe we've got a different bug and we just don't understand it. Okay, so that looks right. Everything is just the white color, which is what we would expect. So it's just this equation that's causing our contrib values, our alpha value, to go to 0 occasionally. And the question is, how is that happening? If we're taking the length of something that's supposed to be renormalized, we know that both Ah, well, okay. I think I see what we're doing here, potentially. Since we are computing the value outside, we're computing these values in neighboring voxels as well. That does mean that we could be more than one voxel unit away from the thing that we're using. We could actually be 2 voxel units away, right? So rather than being 1, 1, 1, it would actually be 2, 2, 2, right? So we'd actually be talking about this value, 28867. Right? That would be the actual value that would be required to ensure that we never go to 0 on the contribution. So it's better, but we still have that problem. So we're just not computing this quite right. The other thing that I would point out about this is, like I said, I would rather have a better math operation to be using here, right? I would rather have something, you know, and maybe I should just do like, so, you know, right, so, you know, I'd rather have something like this, fundamentally speaking, where, like, you know, the thing just goes up forever and, you know, trends towards 0 but never actually hits it. Because I just want to make sure that samples that are closer to you are more reasonable. And you know, so maybe we just use a fall function for that and not try to get that. That way we always are weighting everything, but we just weight things lower as we go. And maybe we need to tune that fall function, but that way we don't have to try and like get that correct or whatever. All right. So now if we assume that the light color is always going to come from the right place, now we go back to like actually computing the lighting equation. Now we're actually blending samples together correctly. Well, correctly is a strong term in this case. We're actually blending colors together in a way that doesn't produce its own set of artifacts, right? And already things are definitely looking better. I just think maybe we've still got some weird issues here, potentially. But you can sort of see that it's starting to get rid of some of the artifacts we were seeing. Even though we still have quite a few to deal with, right? All right, so let's take a look at what we, let's see what we can see here. From the render group itself, we do know that we're stuffing an incident light value of 1, red, right? Full red channel, and we're stuffing that value directly. So if I go in here and look at what I would expect to see, if I was to take the fall off out of it, so we'll leave the fall off part in here, then what I would expect to see is always blending red light with red light. Right? And that should give me pure red everywhere. So once we take a look at the fall off aspect of it, then what we're doing is we're saying, all right, we want to take the light direction, whatever the light direction is, and we want that light direction to now do a fall off on versus what our normal is. And if I put that in, we get a bunch of things that look wrong. I think what we may be doing here is we may be encoding our normals wrong or something. But I don't like the look of that at all. So instead of using this fall off, instead of doing this, which I don't think is particularly instructive, and it's not going to really help us do a great job here figuring out what's going on, I'm going to get rid of the fall off, and instead what I'm going to do is I'm going to stuff the light color that we're going to use in this equation. I'm going to stuff that color with the light direction. So I can just render what it thinks the light direction is at any given point directly. Or not. What's it complaining about there? Oh, that's what it's complaining about. Can't set a V4 from a V3. Everyone knows that. So now if we take a look at what we're getting here, I would say that that's pretty, like, doesn't make a whole lot of sense to me. Now the problem is we're averaging these things together. There's multiple normals in the voxel. So actually I guess the one problem we've got here is that we have no real way of visualizing what all the normals are in there. So we don't really know if that's at all wrong because, you have to remember this is a voxel. And so, for example, right in here, there's this plate for the hero, and all of those normals are going to add it in, like they will affect the normals here and so on, right? But each of those samples is stored separately. So I don't really know. What I want to do is see whether these normals are reasonable. But I don't really have a good way of drawing that, since I have to just draw in the way we're sampling the shader, I have to just draw one value. And so I don't really have much I can do to debug that value directly in the shader, right? Because what I would expect to see, but which I can't necessarily figure out a way to directly visualize, is like all the normals should be the same across all these faces, right? So what that means is that if I were to pick the part of the normal in that voxel, the lighting samples that were coming from these faces should all have the same normal. But I don't know which one of those I'm looking at when I look at the various links in the voxel list, right? So that part's a little bit nuts, and I'm not sure what I can really do to mitigate that. Like, what I want to do is basically draw a bunch of little arrows in here that show me where all the point samples are. The problem is, even though I can go ahead and do that, and that is more or less what we do when we are doing those lighting elements, what I don't have is a way to do that from what the shader thinks they are, right? Because, I can go debug this from the other side and add some drawing in there that would allow me to see where those light samples are and what their normals are. Unfortunately, that doesn't help me with the other part of the other side of it, which is, are they getting read correctly in the shader, right? So one of them is easier to debug, one of them is harder. I suppose we could start by just doing the easier one to debug, because if we find bugs there, then hey, that was free, right? That was, not free, but it was a lot cheaper than what we'd have to start figuring out in order to debug it on the other side. So I guess that's probably the way we should do it. I can't think of a like great way to do it either way, but you know, um, what are you gonna do? So let's take a look at what's going on here. So when we do extract reflectors from quads and we are going to record these normals, we're recording the normal from one vertex in that, you know, whatever that thing was, right? And I guess, I mean, I don't know for sure, but I guess we've never really verified that those are 100% correct values. So even our input is potentially suspect. However, when we were just doing basic lighting, you know, it looked like our normals were pretty good. So I'm not super suspect of this value here, but honestly, if we're going to go the whole way and debug it entirely, we don't really even know that our element normals are correct, right? So we might want to verify even that. But if we then go and look at where this the average light direction stuff is coming from, which is what this directional fall off light D RGB thing is coming from. If we look at where that's coming from, right now we're just passing through those element normals. And so we should never, like those never get modified like anywhere else, right? They get set here. And there's never a place where they get changed, right? So we're literally taking just those normals, which we assume to be correct, but again, we don't necessarily know. And then what we're doing is we're just stuffing that directly into the average direction to light. When we go to encode the average direction to light, which is not there. Yeah. Oh, excuse me. We're going to encode that value. We're just encoding it directly. We pad it with a 0 because it's getting stuffed in a color bitmap at the moment. We pack it in here. We're literally just taking whatever's the packing index and we're sticking in that D value. Right? Like that's it. So yeah, I mean, at least in theory, I don't see a lot of ways that that could really be going wrong. It's hard to say. It just looks really straightforward. And when we were looking at those incident-like direction values, you know, I stepped through here and I did take a look at what we were packing and sending out there, and it did seem like the average direction to light was generally sane. So yeah, I don't know what's going on there. So I guess one thing we could do is say, well, all right, you know, I guess we also don't know. Let's draw the world normal as well. That should be 100% consistent. Just as a start. So that looks very good to me, right? That looks like quite good. I'm very, very okay with that. So yeah, it seems like those world numbers are reasonable. It seemed like the light directions were reasonable as well. So I'm just not sure I understand why something would be going wrong in there. but it kind of looks like something is. Uh, but I get even that. I mean, I guess I don't really know that that's true. If we go back and look at what we're seeing here, we know that we're stuffing pure red into the light source. When we are looking at things with unambiguous normals like here and here, it actually looks like it's giving pretty reasonable results, right? To a certain extent anyway. I would say. So, you know, it's mostly things kind of like up in here that are not making a lot of sense to me. Like here and here. And I guess I could convince myself that that was sort of being done correctly, in that these were places where the fact that there is, you know, additional light normals is getting weighted in more heavily. I'm just not sure. I mean, effectively, the problem that I'm having with it, right, is I just don't really know when we're sort of getting that fall off value in there. I just don't really know what to expect from it. On the one hand, you know, where we've got sort of the world normals, which I think we know are correct, and then we've got the incoming light direction. Dotting those two together should be pretty straightforward and give us the fall that we want. On the other hand, you have to recall that we're summing up a bunch of samples here. And in the case right now where we're stuffing the light direction to be coming from directly away from whatever the surface is, right? Because we're stuffing in a false value there, right? I just don't know what to expect from it. I don't feel like I have a good way of, because we're summing a bunch of them together, I don't feel like I have a good way to really like push structured art through there and get something that I expect out. Yeah, I'm just not sure. I'm interested to see what we look like currently if we do our standard lighting pass. So this includes our ambient light at the moment, right? I'm going to go ahead and take off that ambient light because now it seems to actually be working. So now we'll just have that one, this light source right here. And I'm just interested to see what we end up with. So I guess I would say, you know, it's getting closer to sane. But I still think we've got some bugs separate from the lighting transport, which we haven't started debugging yet. I still think we've got some nastiness going on in there. Let me see what happens here if we add back in the surface reflectance as well. So you know, it's getting a lot better, right? Fixing the voxel interpolation bugs definitely made a big improvement to the quality, right? And so I think we're still behind the 8-ball a little bit here. But we're getting a lot better. I mean, that's starting to look pretty good. And we've just got some, like, you know, why are we getting no light in these sort of underclipped areas? Probably because those reflectors never got any contribution there. Because, like, their distribution point was like underground, or most of their distribution points were underground or something like this. I don't know exactly, but you know, like that's starting to be lighting that you could actually imagine using, right? It's not there yet, but like you can see as I move around, I'm getting some pretty good, like, I'm getting some pretty good results from that, right? And this is something I think we could run on the GPU pretty easily. And that's just pretty cool, right? I'm getting a little excited about that. Like, this might actually turn out pretty neat. You know, I didn't know when I started it whether we would get somewhere usable or not. But that seems like, you know, if I come back here and I look at what we're looking at, right? And I just like try some lighting. I mean, that's great. That's really usable in terms of, you know, a light, and that's not special cased to one light. So this is something that could have as many lights in it as we want. It doesn't cost more to have more lights, really. So I think that's pretty good. And you can see that we've still definitely got some bugs, like that shouldn't have been able to see the light source. So I think if we go and just push a little bit harder on the debugging and get a few more steps down, I think we might actually have a nice real-time lighting solution here, right? That we can have, so we can have kind of nice lights in Handmade Hero, which I want because they're nice and they help the mood a lot, right? Like having just a big old flat game without anything in the game really responding to the lighting at all definitely makes it harder to establish that kind of nice mood, and so I like where this is going, right? That's starting to look pretty cool to me, and that's a good thing. So yeah, I think the next thing we got to do is take a look at why we're getting like no samples or weird sample stuff in some of these areas, right? Where it doesn't really make a whole lot of sense as to why they would be so undersampled. And I don't know if that's because like all the samples are underground or what exactly is happening. Like I said before, I'm not sure what's going on there. But we got to fix that, and then the other thing I think we want to fix is I think our light transport is still kind of busted. I think our raycaster might be slightly busted, or maybe we're like just allowing things that shouldn't be allowed somewhere in there. And then I think we could be at a point where we'll transfer it over to the GPU side of things and try to figure out a way to run it on the GPU for a few iterations so that it'll be reasonably quick, right? Yeah. So if we assumed that, let's go back to our sort of ambient light here. So if we assume like an incoming ambient light there, you can see that really brightens up the scene quite a bit. But we lose a lot of that sort of directional niceness for this light. So it seems like that's almost a little bit too... It's like weird that that's producing that much ambient light. For the final gather. Well, I guess what's interesting about that is we aren't using a divisor here, though. Which explains it. Because yeah, I mean, this should be able to be set to something like this. So really, this should have a divisor there. The number of rays we sample when we do our final lighting should divide the accumulator, right? Right? So for every ray we sample, we should be multiplying whatever the incident accumulator is. That's I don't know why we weren't doing that. Must have had a reason. I'm just not sure what that reason was. So that's more like it, right? Now we can see that there is an ambient gray light, like a skylight, coming in that's sort of omnidirectional. And then we've also got our sort of point light here that we're moving around. So, you know, you get more light in this area and less light sort of in the other areas. I don't really remember where we set the strength of that light source. But again, right, you can just see how this is really starting to come together, right? I mean, that's looking much nicer now. And I think we've still got some nasty bugs in there. I think it'll get a lot better once we get those out of there. But just looking at this, I think even if we move just this to the GPU, it would look pretty cool. You just have some nasty artifacts, right? Like this kind of crap is no good. So we're getting there. I think we're getting there. Yeah. Let's go ahead and do some Q&A here. I can't seem to use the mouse for some reason. Regarding WinCAC, the size of the window determines how many buttons are shown. You can either stretch the window vertically or you can press the up arrow button to make the shown button shift into the other set. Seriously? Why doesn't it set the size by default to how big it should be? Oh my god. Ugh. Alright. Vicar2 said, I think the error in the colors are in the same positions where the normal calculations look funny. Um, yeah, I agree. I mean, like I said, I'm really just not quite sure what's happening there, but I think we've got some uh, I think we've got some like little insidious bugs in some, much like the voxel interpolation stuff. You kind of just have to go in and like uh, validate each individual section, because I think we've got some obvious bugs in. I think the raycaster probably also has some bugs in there. Um, so yeah. Radovich said, not sure if you heard, but someone rewrote depends.exe for Windows 10. No, I did not know that, but that's pretty great. Let me see what's going on with that. That's pretty cool. Well, I'm a fan of that. We don't really use that much on Handmade Hero right now, but that's very good to know. Um, do they have an easy download here? Yeah, that's pretty cool. We might have to take a look at that at some point if we ever have a reason to do so. That's cool. Cause yeah, I like the old dependency walker program. It's cool, but it was definitely like not maintained really. You know. Uh, so it's cool that someone is just taking that on. All right, looks like no queues. So I will go ahead and shut things down. Dragoon X6. So you used Emacs without code completion, now for coder. How do you work without code completion? Code completion. So I assume you mean like structure members or whatever. Because I do use word completion, right? So I often do like that sort of thing. I don't. So code completion is a tough one for me because I don't really want code completion most of the time. When I've had to use like Visual Studio and stuff when it had it on, um, it drives me nuts. But I think mostly that's because of the way it was implemented. So I think code completion would be useful if it was done probably differently. Like I probably never really want code completion. I probably just want a heads up display that shows me the structs and the functions that I happen to be around at that time. Um, because what I usually do, right, is I do that manually by going like, finding the thing that I'm looking for here and then typing in here or whatever. So I have it up and I'm looking at it. Um, that's really what I want. The completion I don't really care that much about, other than obviously when I hit tab, it could use that information to only offer completions that made sense. So that's, a plus. But I don't find that to be a huge productivity problem. The thing that I would probably get at least a slight win from is if it just automatically brought up the things that I was that were involved in the current function, automatically line them up on the left. That's what I would really want, right? Long Boolean. When the lighting is in real time, will that tend to hide some of the more minor artifacts? I don't think so. If anything, the opposite will probably be true. Like, for all we know, we will have some artifacts that only really are evident when we are moving the light around continuously, or lights are moving around continuously. So I would say that we certainly shouldn't count on having any, gifts, if you will, in terms of covering up our mistakes from the real-time lighting. If anything, I think we'll probably end up with the opposite, where, we might end up with a artifact or two that we have to address that is only actually noticeable when you move around. All right. Dragoon 6 was sending a GIF. I can't seem to open it. On my machine, for some reason, like, it's hard to copy things. Like, links don't, in the terminal, they underline, but then they don't open. I don't know why Linux is doing that, but... Sorry, I'm not really sure what this GIF is showing. During the typing, it just looks like... Yeah, I don't really know what that GIF is showing. Sorry. I can't quite tell. I mean, I watched it, but it doesn't really... It just kind of showed the... It just kind of showed, like, a copy of the identifier below where it was being typed, which I'm not sure how that relates to the previous discussion. Showing a heads-up display of the possible... That was not in the GIF. The GIF didn't show that. You sure that GIF shows that? At least on mine, it just types sad, and then it shows sad bar underneath it, and then it just becomes a blank screen. There's no arguments shown there. Am I wrong about that? Maybe the GIF is busted. Sire22 says, I know finding a bad API is not hard, but out of curiosity, did you ever run into an API that was great to work with, one that you seem to magically just click with? I mean, I guess it depends on. I mean, it depends on what you consider part of in the API and how much. Uh, I mean, I think the short answer is probably no. You know, I don't really think I have. There's certainly certain APIs that I feel like have good parts to them, or parts of APIs that seem to be particularly good. Uh, but I don't know. Yeah, I'm having trouble thinking of something that I thought was like a really great API. I mean, the sad fact of the matter is, it seems to me like most people don't spend any time designing APIs, and they don't spend any time practicing or getting better at it either. So most APIs are just shipped by people who have no API design experience, and they don't spend any time making their APIs actually work. Um, I will say that doesn't appear to work very well, does it? Is this supposed to be showing me some dependencies? Um, it doesn't seem to. Try to read this GIF again. Yeah, it doesn't work on this either. I'm using Chromium, but it just goes blank after that part. All right. I'm gonna wind it down soon. Oh, another attempt at the. I guess I could try it in Firefox. Oh, okay, yeah, this one's working better. So yeah, like what I'm seeing in this GIF is works for me. And no, that what's shown in that GIF is the kind of stuff that I don't want. Like, I definitely don't want that. I find that to be counterproductive, and I'm slower with that than I am without it. The reason is because I don't want it to be transient. It needs to be permanent. So when I am editing a piece of code, it has to show me the related stuff permanently on the side. It can't be flickering in and out. That is not useful to me. It needs to be permanently there. So if, the function that I'm in, or the 10-line window that I'm editing right now, or whatever, involves these 3 structures and these 5 functions, the prototypes and structs have to be on the right side in full permanently. And until I move somewhere else and start editing something else, they can't flicker in and out, right? It's just not useful. I don't need you to show me something so restricted, right? Because I know my code pretty well. What I need you to do is give me a heads up display that shows the parts of my code that are related to this part of the code so that I can look at them and glance and make sure that there wasn't something forgotten in those, or see if there was comments in there that I needed to be reading while I'm doing this, you know. And these types of code completion things, they don't really solve that problem, which is the problem that I actually have. Just like telling me which member functions are on this thing is just not a problem I tend to have that much, right? Like, and it's not a problem that's like going to make a huge difference if it solves it for me. What I want is situational awareness, and that requires actual permanent clear display of the related parts of the code. Hopefully that makes some sense. All right. Why this depends program doesn't work, I don't know, but I guess that's the end of that. Bloop. All right. I'm going to go ahead and close everything down. Thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with series at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can play around with it. We also have a forum site you can go to if you want to ask questions. We have a Patreon page you can go to if you want to support the video series. We have a schedule bot that tells you when we're going to be live, and an episode guide, which we will try to figure out how to get updated. I guess it wasn't updating because of a server problem. I don't do the episode guide. That's other folks. Yeah, but I will be talking to Mibdeveloper to see if I can fix the thing that is stopping him from being able to update it. And then that should be back as well. All right, that's it for today. I will not be here tomorrow because I have prior recording engagements I have to do. So I will be back probably the weekend after. Until then, take it easy, everyone. Have fun programming, and I'll see everyone on the internet. Take it easy, everybody.